Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm Otis Kingsman, and in today's episode, we're finding the science behind this major medication method from listener Candy.
I have hyponatremia, and it's a result of a medication. How does a drug stop your body from using or absorbing all of the salt that you consume?
I've always wondered what's happened inside us when we take some form of medication or drug. We're told that they can affect us, but it's difficult to understand how it actually works. Here to open things up and reveal what goes on under the skin is Professor of Medicine from Georgetown University, Joe Verballes.
Now, hyponatremia refers not to low sodium in the body. It refers to low sodium concentration in the blood. And that can be caused by two different mechanisms. The first is, in fact, an excess loss of body sodium, but the more common etiology is an excess of body water due to the inability of the kidney to maximally excrete all the water consumed. You can think of this in the sense of chicken soup. If you're making chicken soup and it's not salty enough, you know how to fix that. You add salt. But if you add too much salt and it gets too salty, then you can also fix that by adding water to dilute the sodium concentration.
Hyponatremia is generally caused by a low salt diet rather than medication. On the off chance, however, it's due to the drugs causing the kidneys to not dilute the urine, leaving the concentration of salt in the blood to be much higher.
If you drink a lot of fluid, I don't care what kind of fluid it is, it could even be a warm English beer, your body reacts by suppressing the secretion of the hormone from the pituitary called arginine vasopressin that controls kidney water excretion. When you suppress the level of AVP, the kidney can excrete up to 20 liters a day, which protects us against becoming hyponatremic.
The role of the kidneys is to cleanse the blood and turn it into urine. Excess water that would dilute the salt in our blood too much is put into urine to be excreted through the kidneys.
But many drugs, for example, some antidepressants, some antihypertensive drugs, some diabetes drugs, cause an inability of the pituitary to completely suppress antidiuretic hormone. And in that case, the kidney cannot maximally excrete the free water. And if that occurs, then if more water than that is consumed, then that will accumulate in the body. That will then dilute the sodium concentration down to a lower level, which we call hyponatremia.
This knowledge that retaining water is what causes hyponatremia begs the question, just how much water should we be ingesting to avoid having too much in our blood?
There, in fact, is no evidence that drinking more water than the amount needed to maintain normal hydration is in any way medically beneficial unless you have kidney stones, and then you should be drinking more to prevent kidney stones. The average amount of fluids necessary to maintain normal hydration in adults is between 2 and 3 liters a day. Average in Western adults is 2.4 liters. And any more than that is not necessary unless, of course, conditions are such that there is excess sweat losses, as might be the case during the current heat wave. In that case, you should just drink to thirst whenever you're thirsty. Your body is telling you you need more water and you should drink more.
Most medication doesn't affect our ability to absorb salt. It affects our inability to excrete the maximum amount of water from the body.
So, Candy, most medications do not cause the body to fail to absorb or use sodium. They cause the body to retain excess water. And the treatment for that is not to take more sodium in. It is to limit the amount of water that is ingested. Again, not necessarily only water, but any fluids that are ingested, because most fluids are largely water.
Thank you to Professor Joe Verballes for helping us find the answer. Next week, we'll be splashing about in this science question from listener Ed.
Why is it recommended to drink cola after swimming in a river? And does it really reduce the risk of getting an upset stomach?
If you at home have a question that you'd like us to answer, send it to our email at chris@nakedscientists.com, Pop it on our website, nakedscientists.com, or on our forum, nakedscientists.com/forum. I'm Otis Kingsman. Thank you for listening, and I'll see you next time.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.